Alrighty, hi everybody. So we already did all of these notes with the substitution method, but we did not yet complete the more difficult questions on this second page. So when we have a system of equations where the variables x and or y are not solved for, aka both equations are most likely in standard form, the first thing that you have to do is pick one x or y to solve for before you can begin any substitution step whatsoever. So if we're looking at number 5, the equations we have, 2x plus y equals -2 and 5x plus 3y equals -8. None of these equations look like the previous page where we had on the previous page like y equals 4x minus 1. Now, number 1 was interesting because both equations had y equals, but the rest of them had one equation that was solved for either y or for x. The only way substitution can work is if at least one equation is solved for y or for x. Now, in this case, number 5, we do not have a variable solved for at all. We have both equations in standard form, so we have to either solve for this x, this y, this x, or this y. Does it matter which one we solve for? No. You can solve for any variable that you want, but you're going to want to try to solve for the easiest variable possible. The easiest variable possible to solve for would be any variable that's 1x or 1y. So the easiest would be if you have like 1x or 1y in your equation somewhere. So if we're looking at number 5, this y is the easiest variable out of the 4 to choose from. This x, or this y. That first y there is the easiest because it is just one single y and no division will have to happen. So what we would do first is take that first equation, 2x plus y equals -2. And we're going to solve this equation for y by subtracting 2x from both sides. And we get y equals -2x minus 2. What we just did is we took the first equation, 2x plus y equals -2, and we just simply solved it for y. Why did we do that? Because the only way that we can use substitution is if we have either y equals or x equals for one of the equations. So now we can begin. Y is the actual teacher. -2x minus 2 is the substitute. What we're going to do is replace y with -2x minus 2. In which equation? Not the first one, because that's the one that we already rewrote. So we can't use the first one. We would use the second equation, 5x plus 3y equals -8. And we're going to straight up replace the y with -2x minus 2 completely. So it's going to look like this. 5x plus 3 times -2x minus 2 equals -8. That is the substitution step, replacing y with what y now equals, which is -2x minus 2. The beginning equation that we had here did not show us what y equals, but now that we solved for it down here, we can use substitution, and now we have an equation we would just solve out. So we would first use the distributive property. 3 times -2x is -6x. 3 times -2 is -6. So here's what we got. 5x minus 6x combines together to be -x. I would add 6 to both sides. I get -x equals -8 plus 6 is -2. And when I divide both sides by -1, I'm going to get that my x coordinate is +2. So I know for number 5, this ordered pair where the two lines intersect definitely is going to be when x is equal to 2. So now what do? I replace in 2 for x into an equation. I can replace it in for this equation here, replace the 2 in for that x right there. I can replace it in for this equation here, replace 2 in for that x here, Or I can replace it in this one, which I rearranged, which is actually the easiest to replace in and solve for y. Because if I take that equation, which is y equals negative 2x minus 2, and I just simply replace in a 2 in for x, I can go ahead and solve this out. So negative 2 times 2 is negative 4. Negative 4 minus 2 more is negative 6. So altogether, my final answer is when x equals 2, y equals negative 6, and that is where these two lines intersect. We're going to do a couple more together before you're going to try some on the worksheet. Now, number 6, again, we have options. We can solve for this x, this y, this x, or that y. But what's important is that you understand which one is the easiest. And the easiest to solve for is always going to be any equation that has one single x or one single y in it. In number 6, the second equation has a single y. So that is the easiest to solve for. So what I'm going to do to solve this one for y is subtract 2x from both sides. I get y equals negative 2x plus 9. And that second equation is now solved for y, and now we have substitution ready to begin. Y is the teacher. The substitute is negative 2x plus 9. So what I'm going to do is use not this equation that we just rewrote, but the other equation that was not used yet, the 2x minus 3y equals negative 11. And I'm going to replace in all that stuff for y. So instead of it saying 2x minus 3 times y, it's going to say 2x minus 3 times negative 2x plus 9 equals negative 11. That's the substitution step. Now we just solve the equation. So distributed property, just be careful. This is a negative 3, so this is going to be 2x, not affected by the distributed property. But negative 3 times negative 2x is positive 6x. Negative 3 times 9 is negative 27. And here we have it. So now, combining like terms, 2x plus 6x is 8x. So 8x minus 27 equals negative 11. I'm going to add 27 to both sides. 8x equals 16. And when I divide by 8, just a coincidence, same answer here for x. I get x equals 2. Now that I have x equals 2, I have half of my answer. My answer is definitely 2 comma something. So now I have to figure out how to figure out what y is. I've got options. I can either use this equation, or this equation, replace in a 2 for x, and solve for y. Now this equation that I rewrote is going to be the easiest equation to use. So I'm going to use that one. So I'm going to take the equation y equals negative 2x plus 9, replace in 2 for x, and solve it out. Negative 2 times 2 is negative 4. Negative 4 plus 9 is 5. So I know that y is equal to 5. Altogether, my solution would be x equals 2, y equals 5. That's the ordered pair where these two lines intersect. We're going to do one more together, and the last one, number 7, x plus 5y equals 4, and 3x plus 15y equals negative 1. We have choices. We can either solve for this x, this y, this x, or this y. But the easiest would be any of those options if we were to have a single x or a single y. So looking at the options, definitely this x right here is going to be the easiest because all I'd have to do is just subtract the 5y, and then I have x by itself. So I'm going to take x plus 5y equals 4. I'm going to solve this for x because that's the easiest variable to solve for. I know we're not used to solving for x, but we can do that, and it's totally fine to use that method because this is the easiest variable to solve for. We're going to get x equals, in any order, 4 minus 5y or negative 5y plus 4, doesn't matter. And now we're ready for substitution. X is like the original teacher. Negative 5y plus 4 is the substitute. We cannot use the first equation for the substitution step because that's the equation we use to rewrite and get x equals negative 5y plus 4. So what we would use is the other equation, which is 3x plus 15y equals negative 1. And we're going to replace in for x this time. So instead of it saying 3 times x, it's going to say 3 times negative 5y plus 4 plus 15y equals negative 1. Now when I go to solve this out using the distributive property, 3 times negative 5 is negative 15y. 3 times 4 is 12. Plus 15y equals negative 1. And look what happens here. In number 7, once we use substitution and we start solving it out, I get a negative 15y and a positive 15y. And when I go to combine them together, they cancel each other out because they're opposites. And I'm left with something that's not true. 12 does not equal negative 1. Because this is a false statement, this means actually that these two lines have no solution because they're actually parallel. And we wouldn't be able to tell if we looked at the equations to start out because they're both in standard form. But actually, I'm not going to do it. But if I were to solve both of these for y, we would see that they were the same exact slope, but different y-intercept, which means they're parallel and they don't cross. So I know we have several practice problems still left on this page, but what we are going to do now is work on the worksheet that the substitute has. So the worksheet has 10 questions, and some of those questions, it's going to start out easy because it's going to be like the ones we did a couple of days ago where we already have a variable solved for, therefore substitution can just begin. So several of them are going to look more like these ones from the other day. So several of them will be just ready to go because you will already have like y equals, y equals, y equals, or x equals. But as soon as you get through some of the easier ones, you're going to see they're going to start to look like these questions. And when you have both equations in standard form and neither one of them has a variable solved for, that's when you have to do the original steps. Step 1 is pick one x or y to solve for, which is technically the very first step in the process. Step 1, solve an equation for x or y, but we did not have to do step 1 yet. We were just learning the process, so we didn't see these harder questions yet, but now we will. So lean on each other for support. I will come back on Friday and I will help you out if any questions that you have, and we can also go over the homework.